Okay, hello. Today I want to talk about the character controller. Let me get my share screen going here. Okay, so back sometime we were talking about the character controller. We had a very simple script for moving a character around with the arrow keys. We cut a copy of the Euler angle Y, and we use that to rotate our character and then translate the character forward using horizontal and vertical keys. And there's some obvious problems with this. Here with on flat terrain, it kind of behaves okay. We drive around and turn and walk and so forth. But if we have that on a terrain, and now we try and drive around through the terrain, because we're directly controlling this thing, it pays no attention to the terrain and it just passes through it. So this is obviously not satisfactory, and we'd like to be able to see the terrain. And the way we do this is with the character controller. As we talked about, it's part rigid body, part collider, but actually neither. It's what moves a character in response to player input. And it does movement constrained by collisions, but it doesn't have to deal with a rigid body. It's not affected by forces, and it only moves when you tell it to move. We talked about the exposed variables that are in the inspector for the character controller, the slope limit, the center, radius, and height. But there are a number of hidden variables that are accessible only from scripting. One is grounded, tells me whether the character controller is touching the ground during the last move. We also have access to the character's velocity, and some collision flags that we're probably not going to use tells where on the capsule, on the character controller capsule, a collision has occurred. And also we have a switch for whether we want to detect collisions or not. This is enabled by default. The two functions that move our character around are simple move and move. Move moves the character with a speed. It's a vector 3, so it should more properly be called a velocity. And the gravity is taken care of by the physics engine. Move is more complex. That takes an absolute movement delta, a distance. And this is also a vector 3 with no gravity. So you have to handle that yourself in the script. I'll show you in a minute. The character collider also sends messages on controller collider hit. So this can be used in scripting to tell when you've been hit by a bullet or run into something. So our simple move C, our first controller, we've got the speed and rotate exposed variables, a Boolean grounded that and a vector 3 velocity. I don't believe I'm going to use these, but they're here so we can see them. And a private controller that we get component in the start function so that it's cached. We're not getting components in the update function. In update, I'm going to catch a copy of grounded with controller is grounded, a copy of velocity with controller.velocity. I'm using neither of these, but they're exposed in the inspector so we can see whether our character's grounded and how fast it's going. So as before, we rotate it using the horizontal axis and a rotate speed and the time delta time. And then we from the vertical, scaled by speed, we get the current speed, which we multiply times the unit vector forward of our character, transform.forward, with the simple move. So this works quite nicely. Works like this. Here we are on our terrain. We're rotating and moving, and we're driving around and we're going up the terrain. We can run up ramps and fly through the air. The physics is taken care of by our controller. So that's the simple move. It's really pretty slick. If we wanted to use the move, which is a little more complicated, also notice I'm using a directive require component type of character controller. This prevents you from removing the character controller from your character. So here I've also included in this one the ability to jump. And I have to have a gravity because I'm going to have to handle that myself. Initializing the move direction to 0, catching a copy of the controller with get component in the awake function. And in the update, I'm testing here now to see if the character's grounded. I'm not going to be able to control the character when it's in the air. It's going to just fall without control. This is kind of like a character who can't turn and run while it's falling. It just falls according to the physics. So this is a test to see if it's grounded. It rotates with the horizontal. It gets a move direction with the transform forward. It scales that by speed. If we jump, we're adding a component to the y direction of our move direction. That's jump speed. That's going to throw our character up in the air. And then I'm applying gravity by sucking some gravity times time delta time out of the move direction dot y. And then I'm using the controller dot move with an absolute delta, the move direction times time delta time. Now, if you look at this carefully, you'll notice that the move direction has a time delta time in it. And then again, I'm using another time delta time. And this is kind of puzzling, but the reason for this comes out of our F equals ma equation for parabolic formula for height versus time in a uniform gravity field. Our F equal ma integrates to a parabola. Y as a function of time is its initial position plus its initial velocity times time plus 1/2 the acceleration times time squared. If we think of each time step as an initial problem, initial value problem, we have our velocity is v of t times delta time. That we could consider be the time delta time plus 1/2 g delta t squared. So our velocity we're getting from the vertical axis, and it has 1 delta time in it. Our y velocity has one delta time in it. Where is it? And whereas that's the 1 delta time, whereas the velocity has 2 delta times in it as an acceleration, and apparently the 1/2 is included. I am a little puzzled by the scaling here, but as you'll see, I tuned this by putting a little cube, rigid body cube in it, and I adjusted the time, the gravity force, so that it matched a falling rigid body. There's a 1/2 that seems to be missing here. But now my little character runs around pretty much like the simple move, except now when I'm in the air, I no longer have control over the character. It just falls without being able to control. Also, it bounces over the terrain when it's not grounded. So that's the character controller with 2 very simple moves. And that's the end of this lecture, and I'll stop recording here, and I'll see you all in class.